So we are going to look at the introduction to biomolecules. Now, just from the word biomolecule, bio means life. Huh? So these are molecules of life. These are molecules of life, or living molecules, we can say. So when you're talking about biomolecules, you have got first carbohydrates, we have proteins, we have got lipids, we have got enzymes, and also nucleic acids. So, if not possible, you are going to finish the whole semester with just these. If not possible, like that's what happened last year. Like the whole first semester just ended at nucleic acids. Very, very important to understand carbohydrates. And the whole first semester work will be concentrated on this, like it's 90% of the work. All right. And so, just to make us understand or to be introduced to biomolecules, a biomolecule, we've said, is any molecule that is synthesized. So it is made, like from what we can see from bio, it is synthesized by living organisms. So you not find this in like being produced by dead things. No, synthesized by any living organism. Okay, that is one thing, and that is one word where even the bio is coming from. So biomolecules, again, you need to also know that they are normally or mostly organic compounds. First, let me ask, what is an organic compound? Like I've seen this question in the exam, they will list different compounds. They ask which one is an organic compound. Does anyone know, or what you know is an organic compound? Anyone? All right. So these are carbon containing compounds, right? I think you stated it in high school organic chemistry that except what? You have got carbon containing compounds, but except what is an exception? So you have got carbonates. I think this was mentioned. I don't know if that is too negative too like that. You have got carbonates. They are an exception, all right, of these organic compounds. I think if I can remember my high school organic chemistry. Wow. So organic compounds are simply carbon containing compounds. So would you say water is an organic compound? Let's see what people say. Hello. Would you say water is an organic compound? Christine, what do you think? Alright, since we don't want to answer, I'll not say anything. Now, another thing when you're talking about biomolecules, examples of biomolecules. Yes, I can get you. I can get you. You have a question or something? Okay. So examples of biomolecules, I listed some, but another one I can include is water. Okay, water, proteins, carbohydrates, lipids, nucleic acids, and just some other molecules. Those are biomolecules. Okay, now we need to understand the role of carbon in biomolecules. The role of carbon, also very important. What's the role of carbon when you're talking about biomolecules? Because biomolecules are most organic compounds, meaning that they're supposed to contain a what? A carbon, isn't it? So, all the biological building blocks are organized around the carbon atom as a center. And because carbon we know that is in group 4, you know that it only has 4 electrons in the outermost shell since it is in group 4. And because of that, carbon needs 4 bonds for it to be what? For it to be stable. Alright? The reason for that is that it has got empty orbitals which lack 4 electrons. So it needs to form 4 bonds. So it can either form single bonds like that, or it can form one double bond, a single bond, and another single bond, or it can form a triple bond and one single bond, right? So it can have all single bonds, or it can have two single bonds and one double bond, or it can have one triple bond and one double bond, as long as you have got 4 bonds here, or you've got 4 bonds as you are able to see there. Okay, so because of this, carbon is mostly used as acts as a chiral center. All right, it will mostly act as a chiral center. I'm going to talk about what I mean by chiral center. So just from what I've said, since carbon mostly gets to form a bond with 4 different things like this, I'm going to introduce a word which is I'm going to introduce that. But these atoms which get to come around the carbon, whenever you have got an element which is at the center, and then there are 4 things around it, you don't have any electrons which are unpaired, or we don't have lone pairs. The angle, if you have got 4 different things around something and that central something doesn't have any lone pair, the angle is always 108.5 degrees. So all these angles between these is always 105, and I mean 109.5 degrees. So it is not 90 degrees as you are able to see here. This structure is in 3 dimension, not in 2 dimension as you're able to see it here. I'm going to show it in 3 dimension as I introduce another word. Okay, so whenever you have got something like this, an atom, a central atom bonded to 4 things, I've said the angle is always 109.5, and the shape that central atom is going to form is a tetrahedral shape. So it looks something like, I don't know if I can show a tetrahedral. I don't know, something like that, a tetrahedral, but I'm going to show that well. But something like this. Okay. Now, since we are saying every time when an atom bonds to 4 different things, the angle is 109.5, and it forms a tetrahedral geometry or shape. Okay, so we are going to introduce a word as the asymmetric carbon atom. So I'm now going to bring in the word asymmetric so that you also understand it, because it is very, very important. So asymmetric. Now the other word for asymmetric that you are going to see in exam papers, if they don't mention asymmetric, they are going to mention chiral. Okay, asymmetric chiral carbon. Now what do we mean by asymmetric or chiral? Something that is asymmetric is something that doesn't that is not symmetric. It just comes from the word symmetric. For example, a human being is symmetric, because if you cut on the middle, what you see this side is going to be the same you're going to see over the other side. So that's the meaning of symmetric. So the other word for symmetric is achiral. Now the other word for asymmetric is chiral. Okay, so when carbon gets to react with 4 different atoms or groups, that carbon we are going to call it as a chiral carbon. Please, all of them should be different. And I mention again, all of them should be different. The four groups which are around the carbon. Remember, we've said when you have got a carbon, it needs four bonds for it to be stable, right? And so here, let me show. Let's say the first group is an ethyl group. So you have got an ethyl group here, like this. Let me put it this side. You have got an ethyl group, CH2, CH3. This is an ethyl group. And then let's say you also have an alcohol group. Now for this one, I'm going to show this shaded line. It has got a meaning. Okay, something like that. I'm going to show OH. And then let's say we have got another group, and that group, let me show it this side. And also these lines I'm putting, they've got a meaning. And let's say we have got a methyl carbon bonded to three hydrogens. And then we have got another group. Let's say we have got another group which is an hydrogen. Okay, something like this. So this structure that you are able to see here has got what we call stereochemistry. So just like you did in high school organic chemistry, you have got a formula, a chemical formula. For example, you're going to see something like C4H8. Now this formula will not tell you how atoms are arranged. So from this formula you have got isomers, right? You can have different arrangements of atoms. Those are what we call isomers. Now you can either have a structural isomer or a stereoisomer or an optical isomer. I'm going to mention all of these in this class since it's the introduction. Now, let me first try to pause. Are we going together? Are we all okay? All right. Please be free to ask if you are lost at any position. So if you see this, you have got an element, and then you see a line which is like this, and then it's shaded. This means that this atom which is bonded here is coming out of the board, okay? Like it is coming towards you. All right, think of it like you are standing here, you are standing here, and then you are giving me something, and I am like you are on the screen, me I am watching you. Now you have extended your hand giving me something. So this atom is coming towards me, all right? Like from the board coming towards me. If you see line represented like this means that this group is going in the board. So it's like the way I'm speaking, right? I've got a screen in front of me, just like yourself. You have got a screen in front of you. Now imagine you are giving someone who is inside the screen something, or someone is in front of you. So that's the meaning of this going in the board. All right. And then if you just see lines like this, straight lines, this means it is parallel to the board. In other words, you are giving someone who is on the side. So this atom is going in the side of the board. This atom is also going in the side of the board. This one is going in the board, and then this one is coming out of the board. So this is the stereochemistry. So you understand this even all the more in organic chemistry. For you who are even doing medicine, organic chemistry is going to be a course instead of a topic. In first year it's a topic, but in second year it's going to be a course on itself. So you're going to even understand even much more deeper. Okay, so let me remove this and write what I wrote again. So you've seen you have got a carbon, and then you have got like an OH group. Okay, let me show Let me show this like it's going in the board. So this one is going in the board, that's the OH. And then you have got also something that is coming from the board towards us. Okay, like that. Let me say this is an hydrogen. And then we have got also, let's say we have got a methyl group, CH3. And then you have got another group which is an ethyl, CH2, CH3. So you can see that this carbon is bonded to four different things, and they are all different. You have got an OH, you have got a CH3, you have got an hydrogen, and then you have got an ethyl. So everything is different. So this carbon is what we call an asymmetric carbon or a chiral carbon. All right, asymmetric carbon or chiral carbon. I've taken time to explain this because as we start going in the carbohydrates, you understand that a carbohydrate like a glucose has got four chiral carbons, and that's an exam question. Okay, now since I've introduced the word isomer. Let's understand the different types of isomers which we do have, because these are going to be important as we get to discuss these biomolecules one by one. Okay, isomers. From what we know, like the definition we know, what is an isomer? Anyone? From what you know, what is an isomer? You people, are we together? Are you able to get me? Yes? Please go on. All right. So our friend has said a compound that has got the same chemical formula but different structural formulas. Is it? Do you have a different answer from that one? Do you have a different answer? Anyone with a different answer? Okay. So an isomer is a compound with the same formula. Yes, please. You can go on. Okay. Wow. Same molecular weight. That's the first time I'm hearing that. Okay, so let's use formula. They've got the same chemical formula. Now, I'm not going to say different structural formulas. Okay? It is same chemical formula. Now, other things can be different, not just structures. All right? So it can be different structures or different arrangement of atoms or like that. Now, because we have got different types of isomers, we now need to know the different types. The first one, which our friend has given the definition, is a structural isomer. So structural isomers have got the same chemical formula but different structures. All right? Same chemical formula but different structures. Let me just introduce you all carbohydrates, monosaccharides specifically. They've got a formula CN, and then you have got water, and then you put an N here. Now, those carbohydrates which have got 6 carbons, their formula is C6, H12, and then O6. Okay, so the ratio of oxygen to hydrogen is 1 to 2. So I'm going to mention common examples which are going to be asked in this course, structural isomers. You have got glucose and fructose. Now, I don't want you to understand this for now, But let me just show the structure so that you see why they are called structural isomers. So for glucose, you are going to see something like this. You have got okay, you have got a carbon. Let me not show carbon. Carbon number one is bonded to oxygen, and then an hydrogen, and then you have got OH, H, and then you have got OH. Let me put the O here, and then the H, and then inside you've got H, and then you have got OH here, and then H. Again, you have got OH here, and then H. And then at the end, you have got CH2 OH. So this is the formula for glucose. Don't worry, you are going to know this. Like, it's very simple. Okay, this is the formula for glucose, and specifically, this is called D glucose. You are going to understand where the D is coming from when I mention another word. So you have got OH here, you have got OH here, and then you have got two OHs here, and then the rest this side are hydrogens. So it should give you the same formula that you are able to see here, the number of atoms. In other words, it makes more like the OHs, if you follow them, they'll make something like an S like that. Okay? This is glucose. And then let me draw fructose. Now fructose, instead of this group which you are able to see here, being this is a functional group. Okay, a carbon double bonded to oxygen is a functional group for all carbohydrates, and this is called a carbonyl functional group. So when the functional group is at the end of the chain like this one, when a carbonyl functional group is at the end of the chain, you call this as an aldehyde. Okay, now in fructose, the same thing that you are able to see here, the very same thing. I'm going to also draw at the end, you have got CH2OH, and then here you have got OH, here you have got H, here you have got OH, here you have got H, here you have got H, here you have got OH. But here, things are going to be different. All right, these things are going to be different here. So here you have got now the functional group, and then at the end you have got CH2 OH. So this group has moved. Now where the functional group is, that is where you start counting. So this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6 here. So at every point where you see a cross, there is a carbon. Okay, meaning that in glucose the functional group is at carbon number 1, but if you check here, carbon number 1 is here, carbon number 2 here, 3, 4, 5, 6. In fructose the functional group is at carbon number 2, and every time you see the functional group not at the end of the chain, at any point on the middle of the chain, whenever a carbonyl is in the middle of the chain, that is called a ketone. Right, it's a ketone. Now because this one has got 6 carbons and it is an aldehyde, you call it uh, aldo aldo hexose. Okay, the aldo is just coming from aldehyde, and then hexose, this one comes from the fact that there are 6 carbons, and then os is just sugar. These are sugars, all carbohydrates are sugar, so that's the name aldohexose. Now this one is a ketone, it also has got 6 carbons and it is also a sugar, so it is called a ketohexose. So meaning that if this was having 5 carbons, it would be called a ketopentose. If this one was having 5 carbons, it would be called an aldopentose. Are we together? Are we moving together? Are we moving together? People, don't be too quiet. Are we understanding or we are confused? What's confusing here? Eh, no, like no, you don't need to know the formulas. Just know where the functional group, that double bond with oxygen is. That's what I'm talking about. I don't want you to know the formula, the structure you're able to see. What I'm saying is that if you see oxygen with a double bond at the end of the molecule. That is called an aldehyde. When you see a double bond with oxygen at any point in the middle, that is called a ketone. That is what I've mentioned. What else are you confused about? So we don't know that 6 carbons is hexose, 5 carbons is pentose, 4 carbons is tetros. Like that's, friends, that we did in high school. That one we did in high school. Pentene, we used to name them butane, methane, pentane, hexane. Where does the hexane come from? 6 carbons. Pentane, where does the pent come from? 5 carbons. Are we still confused? All right. So I hope you've gotten what I was trying to bring out here. So these are called the structural isomers. Why? Because one is a ketone while the other one is an aldehyde. Every time you hear aldehyde, just know that the functional group is not on the middle, but it is at the end of the chain. Every time you hear ketone, just know that the functional group is on the middle of the chain. Right? Is on the middle of the chain. That's what I want you guys to know. Right? So aldehyde is where the aldo is coming from. Hexose 6 is coming from 6 carbons, and then os is coming from sugar because these are all sugars, they are carbohydrates. All right, so this is a structural isomer. Please, you need to know these two examples as structural isomers: glucose and fructose. Exam question. This is an exam question. So another type of isomer, we call them as, let me first talk about optical isomers. Optical isomers. Now, every time you hear the word optical, it has to do with light. Like optical is related to light. Okay, when you hear optical, think of light. So, two examples which are optical isomers, you have got, don't worry, you are going to understand. You have got D glucose and L glucose. So when you see D and L, that means those things are optical isomers. Or you can have glucose and galactose. Now, no. No, these two, I'm mentioning them on the wrong example. So every time you see the D and the L, those are called optical isomers. Now, optical isomers, you are talking of something with the same formula. Let me talk of this same one I've written here. D glucose and L glucose. The formula is C6H12O6. That's the formula for all monosaccharides. And monosaccharides, you have got glucose, galactose, and fructose. These are the three. Those are the ones we'll be discussing in the next class on monosaccharides. And so the formula for glucose is supposed to have 6 carbons. All right, 6 carbons. So I'm going to write just a line. I don't want to show the carbons. Okay, at the first position I'm going to put a double bond with oxygen, and then I'm going to put an hydrogen, meaning that at this point we have got a carbon. All right, at that point we have got a carbon, and then at the end I'm going to put CH2OH. So we have got also another carbon. So from the 6 carbons, I've already used 2 carbons, meaning that I'm only remaining with 4. So those 4 carbons, I'm going to put in them here. 1, 2, 3, and 4. I'm going to write this again. A double bond with oxygen and then an hydrogen. At the end, I've got CH2OH. And then I've already used 1 carbon, 2 carbons, so I'm remaining with 4 carbons. So 1, 2, 3, 4. Now for glucose, at the first carbon here, this is where the functional group is. So I want someone to tell me, is glucose an aldehyde or a ketone? Is glucose an aldehyde or a ketone? Yes, now. Very good. It is an aldehyde. Why? The functional group is at the end. Very, very good. All right. Now, for glucose, what we are going to be seeing is, please, this carbon number 2, just start, okay? I'm going to show this. Put an OH here, and then on the next carbon, put the OH over the other side. Now, I'm putting the O near the bond because it's the oxygen that bonds with a carbon, which is here, not the hydrogen. So don't be confused. In some books, if you see they've written it as OH like this, it's not the hydrogen which bonds with the carbon. That's why I'm putting the oxygen near the bond. Okay, so just write the OH here. On the next one, write the OH here, and then on the next two, write the OH on the same side, like this. Okay, like that. And then the rest which are remaining, put hydrogen. Hydrogen there, hydrogen here, hydrogen here, hydrogen here. So this makes something like an S, if you can see, more like an S. Okay, and then for the other one, swap them. Start with the OH this side, and then this side put the OH here, and then this side put the OH here and the OH here, and then the rest put hydrogens. Hydrogen here, hydrogen here, hydrogen here, hydrogen here. And this one also make like an S, but it is over the other side. Now, where the OHs are concentrated, from what you're able to see, like from your side, is this left or right? Where the OHs are concentrated, is that the left hand side or the right hand side? Like considering your hand, not my hand. It's right. Yes, it is right. So every time you see the OHs are concentrated on the right, that is called D. So this is called D glucose. The D is coming from dextro. Okay. In other words, it tends light to the right. Okay, it tends light to the right. And then for this one, the OHs are more on the left. And so this is going to be called L glucose. The L is coming from levo, Levo. So it tends light to the left. That's a L glucose. And we call it plain polarized light. Plain polarized light. So think of your glasses. If you are putting on glasses, light is going to be polarized. In other words, its speed is going to reduce when it passes through glass. I think this is something that you did in high school. They showed if you have got a small hole, when light passes through a small hole to come out, is it like this? And then when it passes a very big hole, I even forgotten how we used to draw it. I don't know if it is like this or something like that. It is going to be polarized. Like that's why people get to put on sunglasses, because the speed of light is more going to be reduced. That is polarized. Okay, so it is going to turn plain polarized light to the left, and it turns plain polarized light to the right. This is called optical isomers. Friends, are we okay? Any question? All right, thank you very much. Okay, now these same structures that you're able to see here, they can now form what is called what is called stereoisomers. Okay, stereoisomers. Now I don't want to rub this structure which I've written here, D-glucose. So let me just remove here, and then I write stereoisomers. Now, stereoisomers are isomers which have got the same chemical formula, they've got the same structures, okay, but their difference is the spatial arrangement of atoms in space. We are saying spatial arrangement of atoms. Remember when I wrote carbon, I showed lines like this. Okay? So this is the meaning of spatial. Like you have got some atoms that are going inside the board, other atoms are going towards you, others are going on the sides of the board. That is to do with stereochemistry or stereoisomerism. Now, when you're talking about stereoisomerism, this one has to do with the ring forms or the ring structures. Actually, you will not find glucose exist in this form. Okay, glucose doesn't exist in this form where it is straight. Why? Because the carbons are a lot and is going to be unstable. So what we are going to see is that this thing is going to exist as a ring. And how is that ring formed? So please, and take note that stereoisomers are only formed by the D form. Take note of this. They are only formed by the D form. So you can't have L-glucose forming a ring, and stereoisomerism comes in because of rings. Okay, so what you are going to see is this. Let me write how this is going to form a ring. So every time this carbon, which has a functional group, is called an anomeric carbon, and I want you to take note of that. The carbon in glucose which contains a functional group is at carbon number 1. Here. And so you say the anomeric carbon in glucose is carbon number 1. In fructose, if you saw the structure I showed, the functional group, who remembers? The functional group was at carbon number what? Anyone who remembers? Yes, Musonda. So the functional group was at carbon number 2. And so you say the anomeric carbon in fructose is at carbon number 2. Okay, so what happens is that the second from last carbon, Christine, this molecule has got 6 carbons. So the second from last carbon is going to be carbon number what? The second from last carbon. Mm? Is going to be carbon number what? Ah. Okay, to be number 5. I don't know the maths you did in grade 1. Okay, so this is where the second from last carbon is, like carbon number 5. Since this molecule has got 6 carbons. So what happens is that every time the second from last carbon is going to associate with the anomeric carbon. Okay? Meaning that the carbon that is second from last, if this chain had 5 carbons, the second from last carbon would be carbon number 4. If the chain has got 7 carbons, the second from last is carbon number 6. Now this one has got 6 carbons, so the second from last carbon is carbon number 4, number 5 I mean. Let me first ask, is this okay so far? Are we following up to here? Are we following up to here? Okay. So what is going to happen is this hydrogen that is on the second from last carbon, only the hydrogen, which is on the second, not this hydrogen which is alone, the hydrogen which is bonded to oxygen on the second from last carbon, is going to go and interact with the oxygen on the anomeric carbon which has a double bond. So if the anomeric carbon is on carbon number 2, then it will be the second from last carbon with a carbon number 2. So when those hit each other, they are going to form anhydroxide, OH. Okay, so what you are going to see is a ring, and this ring is going to look like this. Remember, you have got an oxygen which has remained here. When the H has gone to hit the O which is on top there, you have got an oxygen that has remained. That oxygen that has remained is going to be here. Okay, you are going to come down, just form like an hexagon, just like an hexagon, like that. I'm going to draw two. I'll draw another one. Okay, like this. Now this OH which has been formed after the hydrogen on the second from last carbon hit the oxygen on the first carbon can either be on top of carbon number one. Okay, this is carbon number one. The carbon which is closest to this oxygen here, that is carbon number one. So it can either be on top or it can be below, like that. Remember, you have got an hydrogen which remained at carbon number one, this hydrogen here. So that hydrogen also can either be down or on top, like that. Now this molecule is going to turn in this way, like it turns in a clockwise way. It will turn like this. Okay, so if this is carbon number one, this is going to be carbon number two, this is going to be carbon number three, this is going to be carbon number four. Okay, this is going to be carbon number five, and then carbon number six, you are going to see where it is located. It's located somewhere here. So since we have already seen carbon number one here, it has come here. It's carbon number one. And then at carbon number two, this is carbon number two. Okay, this is carbon number two there. So what you are going to see is these are the atoms at carbon number two. Since this thing is folding in this way, that means that everything you are seeing this side, they are the ones which are going to be down in this molecule. So at carbon number two, what is down is the OH. Okay, so at carbon number two, the OH is going to be down, and then what is this side is going to be on top. That's the hydrogen. At carbon number three, what is on top is down is going to be the H, and then what is going to be on top is going to be the OH. At carbon number four, this carbon number four here, what is down is going to be the OH, and then what is going to be on top is the H. And then at carbon number five, now at carbon number five, this is where we also have these three linked. So we're going to have this hydrogen you are seeing here is going to be here, and then this group which you are seeing down here is the one which is going to be on top. That's carbon number 6, CH2OH. Now every time you see an OH on top at carbon number 1, OH on top of carbon number 1, this is what is called a beta molecule. Okay, that's called a beta molecule. So since this is coming from glucose, this is going to be called beta. It's coming from D glucose, beta D glucose. Now the same atoms, the same way I've written them, this is the same way we're going to also write them in this molecule. The only difference is at carbon number 1, the OH is now down, the H is now on top. So when the OH is down, that is called alpha at carbon number 1. So this is going to be called alpha D glucose. So this is what we call stereoisomers. Stereoisomers. Okay? Stereoisomers. So these are stereoisomers. These two are able to see. Okay. Are we okay? Are we okay? So every time you see beta and alpha, those are called stereoisomers. Beta and alpha. Now, another type of stereoisomers, of course, which are not here, another type of stereoisomers. So let me write examples of stereoisomers. You have got alpha glucose and beta glucose. Alpha glucose and beta glucose are examples. Another example of stereoisomers, you have got glucose and galactose. So you can see that alpha glucose and beta glucose, they differ at carbon number one, right? You have got OH on top in one, and then in the other you have got OH down. Okay. Now the difference between glucose and is actually the same. This same molecule you are able to see here. So the only way, the only thing that changes is carbon number 4. So this is carbon number 4. Look at this. I've just deleted where there was OH. If you can see, I've removed the OH. Where there's an hydrogen, I'm going to attach an oxygen, and then the H comes inside. In other words, the OH and the H, they swap directions. That changes. It's no longer glucose, it's now galactose. Meaning that even in this molecule at carbon number 4, this is carbon number 4, instead of you having the H on top, the OH down, what is down is going to be H, and then on top is going to be OH. Whenever you see OH at carbon number 4 on top, just know that's no longer glucose but galactose. Okay, that's galactose. But at carbon number 1, the OH is still on top. So that will still be beta. Beta D galactose. So that's the only difference between these two. Alright? Are we okay? Are we okay? So basically, what I've talked about here, this is a nice introduction to our molecules that we're going to talk about, which are the biomolecules or molecules of life.